2. I gotta go back to them. Nice. Oh, that's not under 100. Did we? Yeah.
Why do I only see about half of you with your stuff out? Why do I only see about half of you with stuff out? Come on. We got a reduced schedule today. We got extra to get done.
I got it out. So what you're saying?
No, I want to keep Maroon Day ahead of White Day so that I can do the 4.8b video on Friday so that I can not be here on Monday afternoon. I got appointment, I got stuff to do. So I got to make sure that we are on schedule so that the video is locked in so that the White Day crew has their stuff. Okay? Yeah. Wait. But then I'm gone that afternoon. Yeah, we're screwed no matter what. No, I'd rather screw you guys over than that class because they don't do anything, and at least in here you have Miss LaCroix to ride herd on you. So, all right, first of all, check yourself before you wreck yourself. You all should have done some perfect square trinomial factoring. I don't remember. Did we already check these? Sweet. So then it was progress check 4. All right, those you can check yourself. Checky, checky. The one that says progress check 4. Remember, if the order is backwards, that's fine. The signs have to be right. Every one of these is a plus-minus pair of the same two numbers. What I'm saying is you can't have a 3 plus 2x and then a 3 minus 2x. That ain't allowed, because then you would be switching the negative over to the 2x instead of 3. Okay? But if you said 2x minus 3, 2x plus 3, you said the same thing, just in a different order. That's fine. Okay? Anything about the first set? Again, this was all review, just practicing stuff. We need to make sure that we got this because you will have your quiz Tuesday next week. Yes, ma'am. 6? Okay, the problem with 6 is that they're not both perfect squares, or are they? Is 324 a perfect square? That's kind of a bigger number. It is. So if I do the square root of this one, I got 2y. If I do the square root of 324, what is that larger number? Okay, so I'd say plus 18 minus 18. Just like we were doing with our trinomials, you still have to see, is there anything you can take out? What do 2y and 18 have in common? A number that goes into both of them, 2. So I would take a 2 out, say that's y plus 9. Right? Divide by 2, divide by 2. Our GCF factoring. What do these two have in common? Another 2. Y minus 9. Another 2 out front. And the pair of 2's out front is 4. So I could take the GCF out after I do the square thing, or I could have broken that 4y squared up as 2y, broke up that negative 324 as negative 1 by, oh boy, 2, right? Because then it's 150, 160, oh yeah, 3, 3, 3, 3, right? 81 by 2 is 168, 162. Oh boy, we've been up since 4 a.m. here. What's that? 2 and 162, which is 2 and 81. Okay, yeah, I was just missing 1, 2. All right. We could have broken them up like that to begin with, and then I'd say they've got a pair of 2's in common. So 2 by 2 comes out, leaving a y squared minus 3333 is 81. Well, now this is 4 on the outside, difference of squares. Y plus 9, y minus 9. Okay, so we have the choice of either square root them now, take the GCF out of both of them, or take the GCF out now, then do the perfect square thing. Just like we did with our trinomials. Okay, you have the choice of which way, but you got to make sure that you take all the factors out. All right, I figured that would be the one that we're a little iffy on, just because that GCF business. Okay, check the next set. All of them but 10, you had to do that GCF thing. You either do the square root thing and then take out their GCF, or you have to take the GCF out first, then do the square root thing. Okay, I remember doing these with several of you. Which ones? Which one's sketchy? Speak now or forever hold your pieces. Okay. Okay. Option 1. I would break this up as 2 by 2 by C by C. I'd break that one up as 32 divided by 2 is 16, divided by 2 is 8, divided by 2 is 4, divided by 2 is 2. Whoop. And I'd break up 64 as divided by 2 is 32, divided by, oh wait, I just did 32. 1, 2, 3, 4, 5 more of them. What have they got in common? 2 2's. So I would take a 4 out, leaving C squared, 2, 4, 8 C's, and 2, 4, 8, 16 at the end. Look at your first term and your last term. Are they perfect squares? Yeah, I make C squared by doing C by C. I make 16 by doing 4 by 4. So that's how I finish this off. I do square root of this guy, C. Square root of this guy, 4. It's things squared I always keep the sign in the middle. Don't forget your kid brother at Burger King. Option 2 would be, aren't 4 and 64 perfect squares right now? So I'd womp, womp, and I'd turn that into 2c plus 8 squared. Right? Keep the sign in the middle, thing squared. Do those have something in common? They got a 2 again. But because it's squared, I'll take a 2 out of both of them, but I'll do it twice. A 2 squared comes out. Divide both of them by 2. Divide by 2. Divide by 2. I just have to turn that into a 4 when I'm done. Okay. Way number 1 involves more writing, less thinking, because you combine our old skill with our new skill. Way number 2 says it's less writing, but I got to be thinking. I got to remember I'm not just bringing a 2 out, I'm bringing a pair of 2's out. Okay? And every one of these, besides number 10, they were all done like that. You have your choice of which method. Okay? Think about the stuff that we've been doing so far and what's going to be on that quiz. You're going to have perfect square binomials, perfect square trinomials, and then the quadratic formula that we're getting now. That's pretty much going to be your test. And then we're going to start reviewing for that final. Because 3 weeks from today, final. It's a coming. Okay? Well, actually, yours will be before that, but you get the idea. And then, I do not like how they did this. Oh, I really overthought that. I turned this into a 3-variable system when y'all were asking about it, because that don't look like a square. I thought they just wrote it in the wrong spot. Just straight up cross that problem out. They suck. Let's just put it that way. The book done did a bad, because that don't look like a square. They don't even say in the problem around the square picture frame. If they had just thrown that word in there, we would have been fine. And this is an easy problem. But I was trying to do some, well, if this is 4y, then I'm going to add a width and add a width onto that. If this is 10x, then I'm going to have to subtract a w from it and subtract a w from it, turning the area into a 4y plus 2w times a 10x minus 2w, which is not any of our perfect square stuff that we were doing. And I said, screw it. Okay? But it ain't a square. It doesn't say anywhere in there that it's a square. And it don't look like a square. It does not look like a square. That is a rectangle, dude. All thumbs are fingers, not all fingers are thumbs. All right. So, that means we are ready for 4.6. Was perfect square trinomials. I would like you to factor completely right, and do, no, how do I want to do this at you? No, 5, 8x. And I'm going to turn that into a minus 108. There we go. Get them. Factor completely. You can either GCF then perfect square, or you can perfect square then GCF. I'm just letting you know it's going to have both. Okay. Multiplication chart, calculator. Look back at some of our other examples. Let's see what you got.
Yeah,
Where?
I guess.
Where?
In the back. Can you actually help me?
No.
Come on.
God, if only everything was live streamed and you could take care of all of your work, then you made a choice. Big fat goose egg, bud. You made a choice to not do anything. You made a choice to sit here and play games instead of trying to take care of your responsibilities. Put your phone away. I don't want to see it again. Rest of the semester. Okay? I'm tired of having to tell you to do something when all I want is for you to succeed, but you won't pick up the pencil. All you have to do, just poke a button, pick up a pencil. It's not that hard. Okay, looks like everyone else is finishing up with actual answers. Two is 54, 2 is 27, is 3 is 3 is 3. X. Okay. Way number one. Do your prime factor tree. You break them up. They'll break up like this. I'm not writing the factor tree because I'm assuming you did the tree, if that was your jam. In which case, this is where you should have ended. I'll look for what they have in common, and I see double 3. So I take out a double 3, and that leaves for me 2 by 2 is 4, x squared. Green. Negative 1 by 2 by 2 is negative 4. By 3 is negative 12x. And at the end, double 3. So plus 9. I now have perfect squares. So I get my perfect square trinomial business. It's going to be something squared. It's going to share the sign in the middle. Don't forget your kid brother at Burger King. Make sure you put that 9 out front. Square root of 4x squared is 2x. Square root of 9 is 3. Okay? That's one way. Way number 2 is if I had just done the square root thing to begin with. If I had said square root of u is 6x and square root of u is 9. And then I kept the sign in the middle and did the square. I'm not done because I have to check to see if they still have something in common. What number goes into 6 and into 9? 3. So I remember that I'm taking a pair of them out because it's squared. then 6x divided by 3 is 2x. 9 divided by 3 is 3. Keep the sign. I just have to remember to simplify it at the end. Call it 9 by 2x minus 3 squared. Okay? So depending which way you took, like these are completely divergent paths, but they both end up in the same spot. What I'm looking for is you got the 9 on the outside, you got the 2x, you got the 3, you got the minus, and you remember the squared. So each of those 5 pieces of the answer, because they each came from a different part of the work. Okay? The 9 out front, the 2x, the 3, the minus in between them, and the squared. Now, is there anyone here who took it the wrong direction and did a 2x plus 3, 2x minus 3? Like our difference of squares. Okay. Because if you did, we're just confusing which special form it is. I would just say 1 off, because you still took out the 9, you still had the right numbers, we just goofed whether it was thing squared or plus minus thing. Okay? All right. The final countdown. You got a blank page in front of this? Good. Because right in front of this, we need to do just a quick bit of review. Y'all, you know what? I'm just going to make something up here. 3. Yeah. I would like you to simplify this, like we're all the way back in semester 1. And to do that, do you remember our order of operations? Everyone always remembers PEMDAS. What does it mean? Do you remember us talking about Facebook math and Aunt Kathy arguing with other strangers online? Because there's something else to this. Does anyone remember what the other thing was to this? Why do people argue about something like this? They think multiplication should go first. And we have to remember that division is a lie. Division doesn't actually exist. Now, it's a concept that we can work with, just like infatuation. That's a concept. You can't see it. You can't put it on the table in front of you. Infatuation. I am obsessed with this person. I can't stop thinking about them. That is something that teenagers have to deal with all the time. Most of you, unless you're Airways, right? So we have to understand that this doesn't actually say divide. This says times the reciprocal. Okay? The answer is not 1. The answer is 9. Because I do it left to right like a book. Because they're effectively the same thing. I do addition and subtraction left to right like a book. Because they're effectively the same thing. Okay? We need to know this because I'm giving you today the nuclear launch codes for quadratics, the quadratic formula. We're not doing all the other factoring stuff. I'm just going to give you the formula that solves every single one of them. But it involves having to do things by the order of operations. So, simplify this for me using your order of operations. Or you know what? I'll even make it so you don't end up with fractions. How about that? No fractions at the end. Is that now 10, 7, 7, 5? Right? That's negative 10. Yeah. Now you won't have fractions. Will be nice. Okay? So over 35, not 15. Well, I mean, they are fractions, but they're nice fractions. They're not like trash fractions. Now be careful when you do this. I said simplify. Rounding off a decimal is not simplifying.
So for what I'm doing, I'm kind of just simplifying negative 5 x plus 2.
But what did you do there? Add, subtract, multiply, or divide.
Divide.
Mm-hmm. What's a negative 5 times 2?
Oh, that's what I did.
And then remember, there should still be a plus here. Only if there's an equal sign, because then you can do it to both sides. Like, if you and Jasper are on different sides of a teeter-totter, I can double your mass if I double his mass, because now it's still balanced. But if you're just sitting there, I can be like, 2! I can't just double you, because there's nothing to balance it with, right? Mm-hmm. That's how you, and he flies up on top of the school, okay? What's up?
I was gonna get a drink, but I couldn't puzzle for this. So I got to this part, and
Nope. They're not the same critter. You can't do that. Okay. It sounds like we need a little bit of review, especially before we start having to solve inequalities and stuff on a final. All right. Look through the list. Do you see any parentheses? Can you simplify what's in the parentheses? Can I add an x and a 2 together? Are they the same kind of critter, like terms? No. So I go down to the next one. Is there an exponent anywhere on here? Nope. Do I have any multiplication or division? Yeah, I do. I've got a 5 smashed up on those parentheses. I also have a big line, means big line dot dot divide. Now, when I have that big line like that though, there is an implied set of parentheses over top and bottom, numerator, denominator. Okay, so what they're saying is I have to divide at the end. So, let's take a -5 times this stuff because it's all smashed up on there. We'd have 3 minus 5x. Take a -5 times a 2. -10. All over 35. Okay. Now I can't do that division yet because all that stuff up top is technically grouped together. That's why it's all on the top part of the bar. So I go down to the next set. Do I have any addition or subtraction? Yeah, I do. Up on the numerator, which of those critters can go together? Okay. If you need to split them up like this, so you know what signs go where and what things get combined, you go right ahead. So that's what is -10 plus 3? I heard a -7 and a -13. Which is it? You have $3. You want to buy lunch that costs 10. You're going to owe someone $7, right? Now I can't put the 7 and the 5x together. So, because these can't simplify anymore, just like the x and the 2 couldn't go together anymore, now I can divide. Now I can divide by 35, which I'm going to reduce my fraction. But, y'all, remember that multiplication and division are communist. What you do for one, you do for all. They're both over 35, so I bet their knees hurt. So I have to put this over 35, and I have to put this over 35. They're both over 35. So I divide them both by 35. Okay? This is where those multiplication charts and calculators are going to come in real handy. 7 and 35 got what kind of number in common? It goes in there 5 times because they're both divisible by 7. So divide by 7, divide by 7. What do these two have in common? 5. Divide by 5, divide by 5. So at the end of the problem, we have a -1/5 plus a negative is the same as -1/7 x. You could also call that -1/5 plus a -x over 7 or minus x over 7. They're the same thing, right? 1/7 x and x over 7, same thing. Okay? We got to know this order of operation business, especially the biggest oh crap warning sign here is right here. That because it's all over 35, we had to divide at the end because this stuff was technically grouped together. And that's the thing that really gets people in those social media math arguments, is they don't understand that big bar implies parentheses. because the formula that I'm giving you today has that big bar in it. So we just have to remember to divide last. Okay? Now there's a proof for the formula, or you can just, hey, it's magic, believe it. It's big, it's ugly, it's too much for Mr. Incredible. That is the quadratic formula. It's chunky. If we have a quadratic, ax squared plus bx plus c equals 0. Okay, y'all gonna want to write that, because everywhere that I see an a in my formula, I'm gonna put that number. Everywhere I see a b in that formula, I'm gonna put that number. And everywhere I see a c in that formula, I'm gonna put that number. And then I do the order of operations with it. There's a whole decision tree for factoring and solving these things. It's like a month-and-a-half long unit in a regular algebra class. We've just been doing some bare bones quadratic stuff for you to get into geometry, for you to understand getting through those figures. But if we're going to start solving these types of equations, really, really big deal later in math, I'm just going to give you the thing that works for everything. It's kind of like, how many of you actually go hunting? Okay? Like, there's bow hunting. There's, if I'm pheasant hunting, I'm probably using number 4 bird shot. I'm probably not using deer slugs. Okay? You hit a pheasant with a deer slug, all it does is poof, feathers. Okay? There's nothing left. You use the right tool for the right job. What I'm giving you here, this is like hunting with a bazooka. You are guaranteed to get it. It's overkill in a lot of cases, but it's going to work. Got him. Okay? The quadratic formula is a big honking deal. So you got that at the top of your paper, and they give us 2 examples where things are, they start to write it out. They have it all set up for us. Next to this, I also want you to write, because it's super, super important, parentheses. When you're plugging all of these numbers in, you need to use parentheses. Because if you don't, I guarantee you are going to screw up negatives and exponents. You put a set of parentheses here and here. You put a set of parentheses here and here. You put a set of parentheses here, and then you plug the numbers in. Okay? So it's kind of like you set up all of your plates before you start dishing stuff out. What does it mean when you got things smashed together like this? I multiply. That's another reason to have those parentheses there. Because if I see 4 parenthesis negative 2 parenthesis 6 versus I see 4 negative 2 6, how many of us might be tempted to say 4 minus 2? Right? So we're going to use those parentheses to help guide us. All right, here we go. Whoop. So first up, I can only, I'm going to do example 2 first because everything's on one side. I've got all my stuff equal to 0 the way I want it to. The first thing you got to do is identify what A, B, and C are. What number is in front of x squared? Okay, 1. So in this formula, they already set up parentheses for us. Well, most of them. There should be a negative parenthesis here. Everywhere that I see an A, I'm going to put 1. Okay? What is B? Careful. The number in front of X. Negative 6. This is why the parentheses are important. Because it's a negative B here, it's a negative 6. Which we know is positive 6. I'm going to put a negative 6 in here. How many of us remember goofing that up on a calculator? Remember negative 6 squared? Why does it say negative 36? I thought a negative 6 times a negative 6 was positive 36. We've done this before, right? The order of operations says do the exponent first, then times a negative. I need to put that in parentheses to make it work the way I want it to, because parentheses come before exponents. Okay? And then C is negative 2. I put a negative 2 in there. Our order of operations says we have to do things in a certain order. Do I see any parentheses? Yeah, I threw them all over the place. Can you simplify anything that is inside of parentheses right now? They're all just numbers, right? Negative 6, 1, and negative 2. Do you see any exponents? Yeah, I do. So I got plus or minus square root of. Negative 6 squared is, we just said it, positive 36. Remember, negative by negative is positive. Minus, and then I can do all of my multiplication stuff at the same time because they're all in different spots and have nothing to do with each other right now. So, what's a negative? Negative 6. Positive 6. What's 4 times 1 times negative 2? Times. 4 times 1, 4, times negative 2 is negative 8. And 2 times 1 is 2. Okay, that's square root. It's acting like a set of parentheses. I can still clean up what's inside of it. What do I do with minus a negative 8? I had 8. Remember, add the opposite. So what's 36 plus 8? All right. So I got a 44 in there, a 2 down here, and a 6 up here. This should say plus or minus. Darn book screwing up. Okay. Now go to your multiplication chart. Down that diagonal set of yellow numbers, do you see 44 as a perfect square? So now at the end of the year, I am finally going to break my own rule. We're going to go to decimal town. Okay? Up until now, I've always said you write that as a fraction. Now I'm going to say, nah, it's okay. We can go to decimal town. All right? Does everyone know where the square root button is on their calculator? Kind of depends what you're using, right? Okay. Most phones will have it, but you got to turn sideways to get your scientific. If you're on a regular calculator, it's usually its own button. Sometimes you have to go into a second feature. Like here, it's not one of my buttons, but it's above one of my buttons. So I'd have to go square root of 44. And we're going to do this out to 3 places. Okay. Do you remember your rounding rules? So the 2 tells it to go up or stay the same. Remember, it's 0 through 4 stay the same. 5 through 9 go up. Okay, so it'll be 6.633. Stop that. Frank? Bad. All right. See how it says plus or minus? That's why I've got 2 different lines here. I'm going to have 2 different problems. I'm going to say 6 plus 6 point, I've been up since just before 4 a.m. What was it? 633. Okay. Over 2. Or 6 minus 6.633 over 2. And this is why we have to know our order of operations. It's why we started with that first problem. I leave the divide for the end because those things on top are technically still grouped together. This is why you got to have a good calculator on hand. What is 6 plus 6.66633, whatever numbers? Okay. So this one says 12.633 over 2. What is 6 minus 6.633? Okay, negative negative 0 point, there we go. 633 over 2. See how now I've got a thing over 2. Now I can finally divide. So I'm going to get 2 answers at the very, 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 very end. I take this and divide it by 2. Getting about 6.3, what's that, 165? 3.165, question mark? And about 0.3165, but it's a negative. Okay. I want you to at least see the quadratic formula before you leave this class. All right? Go over to the one next to it. Same thing, but faster. What I start with is, this don't look the way I want it to. They don't have everything on one side. X squared plus 2x equals 3. I need this to equal 0. Who's in the wrong spot? 3. So subtract that from both sides. Minus 3, minus 3. If you need your Paxton line on there, that's fine. We get 3 minus 3 is 0, so I got that part right. Are any of those on the left side like terms? Do they go together? No. So I'll say x squared plus 2x minus 3. Can you write out what A, B, and C are? Okay. So we say A is our invisible one. B is the 2. C, careful, is a -3. Now I come down here, and everywhere that I see A, B, and C, I want you to plug them in. In the formula, everywhere you see A, B, and C, I want you to plug those numbers in. See how they have parentheses there? They're trying to keep us on track, saying don't screw this up. I plug in my A. Ooh, make that a little bigger. I plug in my B. I plug in my C. And you take them a piece at a time. In fact, I want you to kind of put some boxes around there that you can throw this into a calculator, you can throw this into a calculator, and you can throw this into a calculator, those 3 sections, because they're all separated by our order of operations. So a -2 is just a -2. A 2 times 1 is just a 2. That's easy. But that other business, the order of operations says exponents first. What's 2 squared? 4. What is 4 by 1 times -3? -12. So do 4 minus a -12. What's 4 minus a -12? 16. And look for that number on your perfect square list, because sometimes it's there. What's the square root of 16? 4. So those are my 2 final problems. I'm going to get -2 plus 4 and -2 minus 4. Okay? Yes, you go to 3rd hour, not lunch. And how many of you now are just like dog hungry? Because you're just conditioned by the end of this class you get food.